Okay, number 340, a kinematics problem from New Lake. Righty, so the vertical height of a model plane, so it's just vertical, okay, is described by this equation where t is the height in seconds and h is in meters. Find the maximum height. Okay, so basically we've got h, we've got v, and we've got a. So if we differentiate h with respect to time, we get velocity. Velocity with respect to time, we get acceleration. So the maximum height, if you're familiar with kinematics, is, if the rocket's going to do this, here's the ground, here's the rocket, goes up, and in theory it's going to come back down again. So if it's just vertical motion, but when it leaves, it has a initial velocity vector, okay, in the y direction here. But at the highest point, this should we say here y, the y vector is 0. So the key thing is what we need to do here, the trick is to differentiate and get a velocity expression and put it equal to 0. So let's just do that. So velocity is dh by dt. So differentiate this with regards to t. 15 disappears, you've got 12 minus 6t. So we're going to say put that equal to 0, so this expression equal to 0, and we'll find a value of t when the velocity is 0. So 12 minus 6t equals 0, 12 equals 6t, t equals 2 seconds. So just answer the first question. Find the maximum height of the plane. Oh, no, we haven't. We found the time when it's going to happen. Okay, so once we've got the time, we're going to put that back into this original expression. So we're going to put h of 2 equals 15 plus 12 times 2 minus 3 times 4, because 2 squared is 4, so that's going to get minus 12. We're looking at 15 plus 24 minus 12 equals 27 meters altitude. Okay, find the vertical velocity when the plane hits the ground. Now, by the way, this is slightly drawn incorrectly because that suggests something there. At time equals 0, if you put 0 and 0 there, it's already 15 meters above the ground. So you can argue this thing's on a cliff top here, and what's happening is the height of the cliff top is 15 meters. The thing goes up, and should we argue it comes back down, and so it actually will be have a faster velocity than here. Its initial velocity, you go to this expression here, you put time equals 0 in here, the initial velocity is positive 12. So we're going to get an answer here, which is going to be negative. So what we're going to do there is we are going to find the vertical velocity when the plane hits the ground at h equals 0. So when does the plane equal 0? We're going to take this expression and put it into quadratic. So put ht equal to 0, and you got 15 plus 12t minus 3t squared equal to 0. You can cut your losses and go straight to here, or because we're purists, let's take a common factor of 3 out. You got 5 plus 4t minus t squared equals 0. Let's just rearrange it. In fact, times everything by minus 1. You're going to get t squared minus 4t minus 5 equal to 0. T equals, if you were to solve this, factorize it, sorry, you're going to get, okay, what is it? T minus 5 and t plus 1. Does that look right? Yes, it does. Put that equal to 0. So t equals negative 1, which is not possible, and t equals 5 seconds. So what it just said here is when is it h equals 0 is when at time equals 5 seconds. Okay, so we're going to put that there into this expression here. So v of 5 equals 12 minus 6 times 5, and that is 12 minus 30 is negative 18 meters per second. Okay, you have a slight advantage if you've done the year 12 physics. just because your understanding of the up here, when it's at its highest point, the vertical velocity is going to be 0. But yep, you've just got to, you know, the good physics person, physics student from last year would have done a wee sketch. The maths person would have recognized, hey, look, the initial height at time equals 0 is not 0, as I originally drawn it, but it's actually 15 meters up. And we just make the assumption that when the rocket flies up, it doesn't come back onto that landing point or that starting point, but shall we say, keeps on going down. And you know, other things you could work out is the total distance it's gone, but this is what it's asking you. It's asking for the maximum, well, the vertical velocity when the plane hits the ground. Now, I've got the answer here, but there isn't it? -8. So let's just check it out. So this is number 340. Okay, where are we going? We're going to go back one more, and we're going to look at the answers for 340. Let's put 14 in there. Okay, so righty, so there we have it. So we're looking at t equals 2 seconds. H of 2 is 27. I think, excuse me, let's just put this like this. Yeah, so we said at 2 seconds, H is 27. And yeah, put H equals 2, solve that, and there's the answer there. Going back to this here, you know, all this fluffing around here, let's be quick. Turn on the, there we go. Go to equation. We're going to do polynomial F2. We're going to do, what's the highest order? It's 2. So that's going to be -3, 12, 15, and push solve. And you can see -1 up there and 5. So we talk about time, so you can't have -1 as a solution. So that's why we're saying 5. Hey, really encourage you to use this. It's probably quicker, and but maybe, you know, show that line of working, and below it, boom, that there. You know, especially if the numbers aren't nice and the decimals. That's super important. Right.